chance, sir.
Still.
Number of outcomes by the total outcomes, sir.
The possibilities, chances.
The possibility of
Oh, right.
getting
Very
an
good.
outcome from an event, sir.
If I say you will get only one answer, right? But if you say we will get 30 answers for the same question.
What chances are there?
How much chances are there? That is
Number
called
of
probability.
events by total number of events, sir.
Sir, favorable outcomes from an
Times of
event.
occurs
What is meant by favorable outcome?
To the question,
how many outcomes can come, likely can come.
Okay, ma, fine. This all we'll discuss in this concept. As you learned in the 9th standard, you have some ideas, so that I ask the questions. If I ask you how many marks will you get in the final examinations or first periodic test? How many marks will you get it?
Sir, full mark.
Full mark in the sense?
Yes.
sir,
So suppose if it is for 100, so
Sir,
somebody
try to
may
get
get.
100.
Surely will you get 100?
Yes,
No,
sir.
sir. Trying, sir.
So there is a chance. You will try your level
Yes,
best. There is
sir.
a chance to get 100 out of 100.
Yes, sir.
Suppose in Erode now, if you see the weather condition, it is cloudy. Will it rain?
Sir, it may or may not rain today.
Yes, ma, that's it. So it is a doubtful case.
Sir, we cannot confirm it, sir.
Yes, ma, yes. That we cannot confirm it, which we cannot confirm it, which can be expressed numerically or quantitatively, is called probability. Right?
Yes, sir.
So chance of happening an event the chance of happening an event when expressed quantitatively.
Sir, after your assignment, we have to copy in classwork, sir.
Yes, ma, yes.
Okay.
Yes, sir.
Or else you cannot understand. You will concentrate only to note down it.
Yes, sir.
Is called probability. So the chance of happening an event when expressed quantitatively is called probability. Suppose if you toss a coin, getting heads. So probability of getting head, as we know that it is, there is a chance to get 50%, right? 50% is
Yes,
quantitatively it is 1 by 2.
1 by 2.
So that's it, ma. This is about probability.
Okay,
But
sir.
here you need to know some terminals in probability. Then it's good. So let us see that probability of an event. Probability of an event is number of favorable outcomes by total number of possible outcomes. So what is meant by favorable outcome?
Sir, how much time it is likely to occur?
Still. Yes, ma'am. So a favorable outcome is which is required or the outcome of interest. Here favorable outcome is the outcome of interest in the sense if it is asked the question find the probability of getting an even number when we throw a die. So here getting an even number. So here what is our interest? To getting even number is interest. So that getting even number is called favorable outcome. So the favorable outcomes are even number
3,
2,
sir.
4, 6. So this is number of favorable outcomes. 3 by total possibilities, we know that 6. So this
Yes,
is
sir.
1 by 2.
Can you define favorable outcomes one more time, sir?
Yeah, a favorable outcome is the outcome of interest. Outcome of interest in the sense which is required. Here, probability of getting an even number. Here we are choosing the total possible outcomes are 1, 2, 3, 4, 5, 6. What is required here? Required outcomes
Sir,
are even
even
numbers.
So only even numbers, sir.
Only even numbers. So an even number is our interest to get it here. So that the even number is called favorable outcome. So the even numbers
yes,
are 2, 4 and 6.
yes, sir.
That's it. So this we'll use experiment. What is experiment in probability? So here an experiment in the sense an operation which can produce some well-defined objects. An operation which can produce some well-defined objects. Next, usually we'll use frequently random experiment. So what is meant by random experiment? This is very, very important. So an experiment is said to be random experiment. An experiment is said to be random experiment if it has more than one possible outcome. More than one possible outcome. And it is not possible to predict the outcome in advance. Predict the result or outcome in advance. So if these two conditions are satisfied, then the experiment is called random experiment. Suppose tossing a coin. What will get it, ma? Tossing a coin.
Sir, head tail,
Sir,
two
either
outcomes.
head
So we
or
do not
tail.
Head
know.
or tail.
So is it satisfy the first condition or not? Let us see. We'll get either head or tail, right? It has more than one possible outcome. Is the first condition satisfied or not?
So
Yes,
satisfied.
sir.
Then we have to verify the second condition. If you toss a coin when it is in air, can you say that whether it falls heads or tails?
No, sir. We can't
When
predict,
it
sir.
reaches ground only, we can say that. So this is the second condition. It is not possible to predict the outcome in advance. So tossing a coin satisfy the above two conditions so that it is considered as a random experiment. Even throwing a die also.
Only for experiment, any example, sir?
A card is drawn from a well-shuffled deck of 52 cards.
If it is the face is upwards, we can predict the result in advance what we are getting it, right? So that comes under experiment only, ma'am. If the facing is downwards, so we could not predict the result in advance. That is random experiment. Is it clear, ma'am?
Yes, sir.
So one more time, sir.
Now let us take the a playing card, ma'am. Suppose this is number 8. Hearts, some value. If it is facing is towards us, so by seeing this 8, can we Can we predict it will get the heart 8 or not?
Yes, sir.
So that
Sir,
is
we'll
only
get
that is only experiment. We are selecting 8 from hearts from well shuffled card.
Yes,
That
sir.
is only experiment. Why it is experiment in the sense? Why it is experiment? The first condition is the second condition is a fails because it is not possible to predict the outcome we need. But by seeing these cards, we can say that it is 8 from hearts. So we can predict the result. It is 8 from the hearts, isn't it?
Yes, sir.
So that it comes under experiment. If we could not predict the result in advance, then we'll say that the experiment is random experiment.
Okay, sir.
So the next one is equally likely events. 2 or more events of random experiment are said to be equally likely events. Equally likely events if each one of them have an equal chance of occurrence. Do you understand what is it? Equally
Yes,
likely
sir.
events. 2 or more events of random experiment are said to be equally likely events if each one of them have an equal chance of occurrence. Suppose probability of getting
Also tossing a coin.
tail.
Coin, sir.
Throwing
So
dice.
probability of
I mean,
passing
throwing
coin.
6 dice in a. I mean, single time.
Single die,
At the
6
same time,
possibilities.
throwing 6 dice. What are the probabilities of getting a particular number or something?
So equally likely events in the sense, if you're tossing a coin, we'll get head and tail, right? Possibilities. So what is
Yes.
probability of getting tail? Is 1 by 2.
So 1/2.
Probability of getting head
1/2.
is also 1
1
by
by
2.
2.
So the probability of each event getting equal chance of occurrence. So those are called equally likely events, right?
Yes, sir.
So if you toss a throw a die 3, 4, 5, 6, probability of getting 1, what will get it? 1 by 6.
So 1 of 6. 1 by
Yes,
6.
ma'am. Probability of getting 2,
1 by 6.
1 by 6. So probability of getting 1, 1 by 6. 2 also 1 by 6. 3, 1 by 6. Till 6 it is 1 by 6 only. So probability is equal or not? If each one of them an equal chance of occurrence, each one outcome also having equal chance of occurrence, then these are called equally likely events, right? Trial. We'll see about the trial. What is trial? So performing a random experiment. A random experiment is called trial. The example, tossing coin or throwing a die. So these are called trials. And the next one is outcome. What is outcome? The result of random experiment. Result of a random experiment is called outcome. In this, the first case, tossing a coin will get head or tail. And here it is 1, 2, 3, 4, 5, 6 when we throw a die. These are outcomes. And the next one is sample space. The set of outcomes. Set of outcomes of random experiment. So we'll use these brackets to represent set. If you use these brackets to represent the set, that means the elements order is immaterial. First we can write tail, next we can write head. So that's the meaning of that. And in the second case, 1, 2, 3, 4, 5, 6. This is
We can change the order, sir.
yes, ma. Order is immaterial.
Okay, sir.
Sample point. Sample point is each element or a member of sample space. So each element of sample space. So we can write either head or tail. So it is like outcomes only. So those are called sample points. So what are the terminals newly we'll use? You should know that. That's it. Next, event.
Sir, can you repeat sample point, sir?
Sample point. So this is sample space, right? The above one is sample space. In this, each outcome, either head or tail. Head is one sample point, tail is another sample point.
Yes.
Similarly, in 1, 2, 3, 4, 5, 6 also, each one is one sample point. Next one is event. So subset of sample space. Subset of sample space is called an event. So subset in the sense we can take in set format all the possible outcomes or at least one possible outcome. Either only H or only T or HMT. So these are called events. And only one or only 1, 2, 3 or all 1, 2, 3, 4, 5, 6 or any two. It is average. These are all called events. If it is each point we have taken as a subset, then this small subset which consists of only one outcome is called simple event, right? So if it is combination of two or more, those are called compound events. That is the difference between the simple event and compound event. And two more important events are, one is certain event.
Sir, certain events, sir.
Yes, ma'am. Certain event, this is also called sure event. And the other one is impossible event. When it is said to be a certain event, when it is said to be an impossible event. When the probability of an event is exactly 1. So that is called sure event or certain event. When the probability of an event is 0, then it is called impossible event. So from these two concepts, we can conclude that the probability of an event is always from 0 to 1 only. The range of probability of an event is from 0 to 1. If it is less than 0 and more than 1, we could not get the probability of any event. Right? Probability of an event is always less between 0 and 1, including 0 and 1 also. That means from 0 to 1. Is it clear?
Yes, sir.
What about rest of all? If anybody has a doubt, let me know. We'll discuss it.
Minimum is 0 and maximum is 1,
Yes,
sir.
yes, that's it.
Okay.
So deck of cards. Total how many cards are there?
Sir, 52.
52. Yes, 52 divided into
So 4.
4 parts. So
So
what
14.
are those? The first one is
Sir,
Spade,
spade,
club, heart,
club. Next, heart,
heart and diamond.
Diamond and heart.
yes,
Diamond.
heart and diamond. Each one having 13 cards.
13 cards.
In these 13 cards, in each case, J, Q, K are called face cards.
3 face cards are each.
Yes, ma'am. Each one having 3 face cards. Ace is not a face card as well as not a number. So ace is neither face card nor number.
Yes.
So, but usually the first number we will call it using that term, no sir? 1.
No,
So
no.
one will
Ace
be
we
ace.
cannot. No. In playing cards they will use,
Sir,
but
one also will be ace and
no.
King.
14
After
will be
the king,
also
A
ace.
will be the largest
yes,
amount.
ma'am. After
sir.
the king, A is the highest value in playing cards, but
Sir, we can use first also, last also, no sir?
we cannot use at first,
Okay.
right?
Sir,
You
in
don't get the
playing cards,
confusion.
they will use it first also, sir.
Ma, in playing cards they will use, but in mathematically we will not use it as 1.
Sir, yes, sir. It is the greater amount than king, sir. Ace.
So that only I mentioned it is neither face card nor number card also.
Write all the 13 cards of only one, sir.
Sorry, ma?
So one time can you write all the 13 cards?
Yes, ma. We can write all these 2, 3, 4, 5, 6 till 9, 10, J, Q, K, S. This is the order. This is the order, ma. That's it.
Okay.
But you keep in mind, S is neither face card nor number card. Right? Usually we'll get the confusion here only. That's it. Ma. So you just go through this and try to start the exercise. In this concept, if you have any doubts, we'll discuss in the next class.
Sir, how many introduction?
This only, ma, which I'm going to share this PDF that you can write it. You need not write the whole, which is given the whole in the textbook. Exercise, which questions can you complete? Those you can write it. Not maximum number of questions. At least 2 to 3 questions which you can complete based on 9 concepts. You try it. If you could not get it, we'll discuss in the next class.